everyone. So, quick show of hands, who has Netflix?
Yeah.
Who is still asleep? Okay, not so many, so great. I'd like to tell you a story of how we're building the world's largest studio at Netflix. But first, my name is Lauren Tan, as Nick and Mel have kindly introduced me. You can find me on the interwebs as Sugar Pirate or Protego. I'm rubbish at reserving usernames, as you can tell by the underscore, and not being able to spell potato. You might be wondering why I'm here today, and I'm here today because of my many skills. One of them is philosophy, which some would say I'm pretty good at. I also have an extensive knowledge of Star Trek, so ask me more about that later. I have a bit of a strange accent. Even though I am Australian, I grew up in Singapore, and then I moved to Melbourne, went to Monash for uni. Then I moved to the States, first to Boston, then to California. And since then, I did my first ever talk at RubyConf in 2015, and I've been doing talks ever since, mostly about JavaScript or Elixir. And this is actually my first ever Ruby conference, so hello everyone. And, of course, customary dog photo. I did get a dog when I went to America. Her name is Zelda, as you can tell from her costume. All right, now that you know everything about me, let's start from the beginning. So around 20 years ago, a little company called Netflix did something pretty crazy. We sent out DVDs in the mail because who likes going outside anymore? And even today, we're still sending out DVDs to our customers. A decade after that, we shipped 1 billion DVDs, and then we did another crazy thing. We thought, hey, this internet thing is pretty cool, so let's stream video on demand. And despite what other people said about us, we continued to innovate and to make things better. And even today, we continue to make big bets to give people more of the content that they love. So today, Netflix is clearly the best website on the internet. We even have our own memes. In 2018, successful companies don't IPO. They have memes. And that's how you know you've made it. Oh, my picture is missing. In more serious terms, the work we've done on our originals have gotten more recognition. This is supposed to be a screenshot of us winning an Oscar this year for our original documentary, Icarus, but it's not loading, as you can see. So that's that. And now all my pictures are missing. Yeah. I got disconnected from it.
It's Ruby. Try a good Ruby one.
Let me try and refresh it. It's okay. It's okay. So some of the work the studio engineering team has done, I'll just describe the picture to you. This was supposed to be a picture of Variety, which is an online American magazine. And it was an article showing us showcasing some of the work that my team has done. So the studio engineering team, which I'll talk a bit more about. But despite our success, we don't want to get too comfortable. We're continuing to do crazier things and producing our own Netflix originals. We're pivoting from being just a streaming service to also becoming a studio, and it hasn't been an easy task. And now actually, I think all my images are missing. That's not good. Let me refresh this page. No, I think I have offline one. Because it got disconnected halfway. That's so weird.
I can reconnect you.
Okay.
Capital when?
March 2018. The magic of internet. See, there's one thing I don't miss about living in Australia is the pretty terrible internet. Oh, nothing is showing up. Oh. How do computers even work? All right, sorry about that. Okay, so let me backtrack a little bit. So despite our success, we didn't want to get too comfortable, and we wanted to keep innovating, doing crazier things, and producing our own originals. So we're pivoting from being just a streaming studio to also becoming a studio, and it hasn't been an easy task. Ultimately, we're doing this because we want to produce the best possible product for every single one of our customers. People's tastes are really broad, even in a single market. So members who love blockbusters, Korean dramas, animes, zombie films, will find that Netflix fills their homepage with relevant and interesting titles. But it took us a while to get to this point, and we have an even longer and more arduous journey ahead of us. So once we got started with internet streaming, it took us a while to get really good at it. But when it came to content, it was another story. So when we did start out our first project, it was extremely manual and extremely inefficient. We had a ton of Google documents, we had a ton of spreadsheets, and at the time, obviously we didn't have to automate anything since the volume of content was so low that it didn't matter. At some point, we even had fax machines, I believe. We had Post-it notes on monitors. We had graffiti in the bathroom. Any surface that you could write on, we wrote on to take notes about all these things we were making. And eventually, after much effort, we produced our first ever Netflix original. Does anyone know what that is? It's not. Yes? That's a common misconception. Our first original is actually Lilyhammer, which was a co-production with another studio. But yes, Horse Cause was indeed our first owned original, and it was our first project that demonstrated that we were onto something. So as our studio grew, we continued organizing everything with spreadsheets, which mostly worked for a while, but very quickly started to not scale. So a couple of years ago, a tiny engineering team formed, and we got to work to answer this question. How do we scale? How do we do this at scale? So we released our first ever studio application called Origin Story a few years ago. Origin Story is a hub for production data, and we collect everything from where and when we shoot, how much it costs us, who's on the cast, the kind of camera they use, who's on the crew, and basically storing any and all kinds of production-related data. So back then, Netflix was still largely a Java shop, and it still mostly is. But our first application was built with Rails and Ember, thanks to the suggestion of one of our first engineering managers. And since then, that little team has grown into the studio engineering organization. Right now, there's about 60 of us, and our mission is to transform Netflix into the most efficient studio on the planet. And we want to help storytellers around the world bring the most creative and compelling original stories to life. Our applications span the entire life cycle of creating a Netflix original, from pitch all the way to post. And this time, we're not just turning spreadsheets into applications. We also work very closely with our data science teams to create step function innovations, the kind of 10x improvements that really move the needle. Our strategy of betting on original, compelling content seems to be paying off. Don't want to jinx it. We hit 100 million paying subscribers in April last year. And now we're at 118 million. And we actually have more international members than members in the US now, which is pretty crazy considering Netflix only went global in 2016. And we're now in more than 190 countries. So we're spending a ton of money in original content. That's a lot of zeros, $8 billion. And it's really exciting for our team because the whole company is behind us to succeed. But at the same time, it's also incredibly challenging building this studio from scratch. Challenging yet satisfying, knowing that we're helping to reinvent how TV and movies are made. And that leads us to why I'm here at RubyConf. So why do we choose Ruby to build the Netflix studio? Before we can answer why, I need to give you some context about Netflix and the kind of environment we operate in. So the first thing that you need to know about Netflix is that our culture is very unique. Some of the key aspects of it are freedom and responsibility, context, not control, and being highly aligned yet loosely coupled. So freedom and responsibility helps us avoid an unhealthy emphasis on process. In our case, we were free to choose the right tool for the job. And even though Netflix was traditionally a Java shop, we went with Ruby because we thought it would be a better fit for the kinds of problems that we wanted to solve. which are very different from the kind of high scalability issues that the Netflix.com product has. Most of our JVM-based tools and services and our open source work exist to optimize for high availability and scalability, and these are problems we don't have. Now, just about a week or two ago, it was Ruby's 25th birthday, and it really got me thinking about why we chose Ruby in the first place and why we continue to use it. And one of the things that really stood out to me is all of you, the Ruby community. At Netflix, we don't hire brilliant jerks, and the Ruby community is one of the nicest communities out there, and has also popularized many good ideas, such as test-driven development, ergonomics, developer ergonomics, and productivity. And that code is read much more often than it is written. And I think most of you can agree that Ruby is pretty easy to be read. Another thing that sold us on Ruby is the fact that the Netflix studio space is constantly evolving. Our user base and the processes they use is evolving by the month. We need to be able to react to change pretty quickly. And we're still in a period of immaturity. We often don't really know what we're doing, we don't know what we're building, and we're trying to innovate. And Ruby helps us do all of that. It helps us explore and push the boundaries, and helps us think about how we can do things differently. So our challenges are not so much about throughput and raw requests per second, but rather with the fact that we're collecting such a large amount of data about the TV and movies we produce. And this data lives across in Netflix in many different systems. So our technical challenges are really that we're building data-intensive applications in a highly distributed environment. When it comes to technology choices, it's always a trade-off. And what are you optimizing for? The number of users we support are in the hundreds to the thousands at most. But collectively, these hundreds of people control billions of dollars in content spent through our applications. So again, it wasn't really about high scalability for us. It was really more about the amount of money that was involved, how little time we have to innovate, and the challenge for us was really in reducing the time from idea to business value. To be honest, it didn't really matter what language or framework we chose to solve these problems. We could have just as easily chosen Python, Elixir, Go, or an obscure language like Scala. But our customers don't care what language we use. Now, this is one of the slides in my favorite talk at All Things Open last year. Massively scalable systems require significant engineering effort to build and operate, but complex socio-technical systems are even more challenging. Now, as an industry, we tend to try and solve complex problems with technology, but the truth is that tech alone is not a replacement for a broken culture. And if I think about the reason why I choose to continue to use Ruby in my team, it comes down to a very simple reason, that Ruby makes my team happy, curious, and eager to innovate. And how many programming languages do you know that people actually love writing? I think you'd find it to be quite difficult. And most importantly, with the kind of work we do, reinventing the way TV and movies are made, it's really important that we have empathy for the people whose work relies on ours. Now, in more concrete terms, I'd like to show you what we've done as a team. Ruby lets us solve our users' problems really quickly and creatively. But as our team grows, one thing we're always thinking about is developer productivity on a larger scale. And like Ruby on Rails, we've learned to share the pain among ourselves using well-built and maintained conventions. So before we continue, for context, when we first started out writing these studio applications, they were all extremely isolated. Everyone, you can consider every single one of them a separate monolith. And there wasn't a lot of sharing, and we reinvented the wheel a lot. And I think we had our mantra at the time was just ship it out, which is pretty cool. Now, these days, you cannot go to a conference talk without hearing about microservices, so I'm sorry. But as you're probably aware, Netflix has thousands of microservices in production, and our organization is no exception. So after our initial mantra of just ship it out, we quickly realized it wasn't going to scale for us, and so we had to take a step back and reevaluate. Now, one thing I want to stress is that we transitioned to microservices not because it was cool, but because it was necessary. And it really only makes sense if your company is large enough. If you're starting out a new project with microservices, you might want to reconsider. You are adding a lot of complexity with very little utility, especially if you are in a small team. It's really easy to assume that technical choices or technology choices are the only reason why a business is successful. And just because big companies like Netflix use microservices does not mean that you need to use microservices as well to be successful. Like most things in technology, nothing is a silver bullet that will solve all of your problems. Microservices are really not a technical solution. They are a way to optimize the communication within your organization, and they help you stay productive as complexity grows in a growing organization. Now, going back to that culture memo I mentioned earlier, because our teams are highly aligned yet loosely coupled, microservices work really well for us. And it's really more efficient for a single team to own and maintain a solid service that everyone needs, instead of rebuilding the wheel each time. So now I'm going to talk about some of these things that we've built and extracted. So after our realization, we had to quickly scale the way we were building through applications, because we weren't just building one application. We were building like 10 at a time, and it was really a lot of work that was going into this process. And so we started investing really heavily in tooling, making it a lot easier to use Ruby in production. For example, we now have a tool called Newt, or the Netflix Workflow Toolkit. It's a really cool logo. It's a command line tool that automates setting up production-ready projects. And when we bootstrap a new application, Newt is what we use. It's written in Go, and at its core, it's actually a very simple concept. So in Newt, you bootstrap a project with an app type, which is you can think of as a blueprint. And there are a lot of app types that people write and contribute for different languages and frameworks, including Ruby. And this also integrates very easily with Docker. When you initialize a new project, Newt does a bunch of things for you. For example, it'll set up a Git repo in our private Bitbucket. It also sets up build pipelines in Spinnaker. Spinnaker is an open source multi-cloud continuous delivery platform that was created at Netflix, and it's really awesome. So a Spinnaker pipeline is a workflow for deploying your application with a specific cloud provider. In our case, it's usually AWS. So for example, in this pipeline here, if you look at the diagram, we're configuring Spinnaker to spin up a Jenkins build to run our tests. And at the same time, we're also firing off a request to bake our code into a deployable image artifact. And if our tests fail, the pipeline's canceled. If it passes, we continue the bake process, and then we deploy our application. So all of our applications have continuous delivery out of the box. Newt also sets up Jenkins for you, which we use as a general build server. And once your application is in production, you have access to a whole suite of availability and monitoring tools that we have developed at Netflix. So this dashboard, for example, gives us insight into the runtime performance and health of our systems. Tooling aside, Ruby is just a dynamic and fun language in general. So one of the applications I manage is called Orion. It ETLs data from multiple services and then creates calendar events, which we display to our users. So we regularly bulk insert a lot of these calendar events at very regular intervals. And our initial naive approach was using vanilla active model instances. That was a really smart idea. And that was taking up too much memory to instantiate in bulk. So we wrote a very tiny class to emulate its API without the overhead and drastically reduced memory pressure when we were doing these bulk inserts. And because the API was the same, it was a drop-in replacement in our code. And then we could then make use of the very active open source community that Ruby is so well known for to do things like quickly insert all of these records into Postgres. Now, another thing we've extracted is authentication. This is actually my favorite part of the talk. So a couple of months ago, we ripped out authentication from all of our applications. So we deleted devise, which felt great. Deleting code is like my favorite thing. Now, backing up a little bit, many of our users' workflows spans like multiple applications. So when they go to one app, and then another app, and another app, and another app, they have to log in over and over and over again. And this is it was an extremely bad user experience. It was very fragmented, and it was very annoying. So if you had to use like 10 applications every day, you would have to log into each one. That's very frustrating. So we write all of our UIs as single-page applications that are separately deployed from our APIs and microservices. And we currently deploy them with a static hosting service we built called Bolt. Bolt is a Lightning deploy system that integrates with other tools across our company. But more importantly, it allows for a single sign-on experience through a shared authentication layer. So Bolt is an implementation of the Lightning deploy strategy. This was demoed by Luke Melia at RailsConf a couple of years ago. And it's set up with Amazon S3 along with Redis and fronted by Apache. I'm not going to go into too much details into how this system works, but you can check out this talk if you want more details. And so this is a very simplified diagram. Bolt integrates with Meacham, which is our Netflix internal identity service through an Apache module. And Meacham, in turn, integrates with multiple identity providers like Google so that our employees, our contractors, our partners, and vendors have access to our applications. And more importantly, Meacham also provides a single sign-on experience and other cool stuff like multi-factor authentication. So when a user first comes to one of these Studio applications, if they're unauthenticated, they get redirected by Bolt to this Meacham login page. And then what happens is that the request never actually hits our applications if the user is unauthenticated. So with this approach, it was pretty cool, right? Our developers could focus on actually building out the important pieces of the business logic that our studio required, while leaving authentication to be taken care of by a focused platform team for the entire organization. So how does this all work? So after you authenticate, you get the browser receives a JSON Web Token or a JOT back from Meacham. This token is then set up to have all the appropriate scopes that allow it to access the various services that it needs to access. And then the APIs in return also integrate with Meacham to validate that token. And when the request finally hits our API, we also receive user metadata in the request headers after going through that Meacham proxy. And when the request finally hits, for example, a Rails application, as you saw in that previous diagram, we receive all of these different user claims in that header for that request. And this kind of acts as like a current user across all of our applications. And with a very standard set of claims, it's easy for applications to make use of user-specific metadata in their applications. Now, that's all fine and dandy when a browser client is hitting your API, but when our APIs communicate with other APIs, we make use of another tool called Metatron, which is a system for establishing cryptographic identity among users and applications in the Netflix ecosystem. Then in return, we also use Metatron TLS for providing certificates to simplify this integration for our services and clients. And it just makes working with a lot of different microservices a lot easier. And because a lot of our applications use Faraday, we also wrote a simple Faraday adapter since it's very popular. Similarly, we've also extracted authorization into a separate service. We manage application-level roles and capabilities in a service called Protego. It provides role-based access control at a project and a partner type level. And we also use this to manage what our external vendors can do with our production data. So for most Studio applications, we typically use Pundit in conjunction with Protego. And unlike Devise, we didn't just delete Pundit, but we just store our policies in a separate service. And then we manage the mapping of users to specific roles through Starship, which is another service. We have a lot of services, as you can tell. When we produce content, we don't always work alone. And typically, we work with a lot of different partners and vendors who need access in some form to our production data. But obviously, you don't want to give them all the data, only the data they actually need to use. So Starship helps us do all of that. It helps us onboard these people and give them the appropriate permissions for the production that they're working on. And our production admins get a UI where they can manage those users who need access to that data. And in addition to services, we've also built many internal gems that we leverage. So far, we've only open sourced one of them. There's going to be more to come. And the first one we've open sourced deals with JSON API spec serialization. So again, for context, many of our single-page applications are Ember applications. Some of them are React applications. And as a convention, most of them follow this JSON API specification for APIs built in JSON. We used to use active model serializers, but unfortunately, it's not as actively maintained as it used to be. And its performance wasn't really as optimized as we had liked. And on average, we found that 50% of the time serving requests, so 50% of the time, half the time, serving requests was being spent on serializing the data into this format. And we knew we had to go faster. So one of our teams wrote a gem that was optimized to do just that, serializing a generic Ruby object into this JSON API schema. And our benchmarks showed 25 to 40 time improvement over active model serializers, which is pretty good in my book. All right, so another common application concern are feature flags. Feature flags we use really heavily to let us, I guess, deploy really frequently without necessarily halting for work in progress. And as you might have guessed, we have a service for it too. This generic service is known as Fast Properties, and this UI was rolled into Spinnaker, which is that multi-cloud delivery system I told you about earlier. So it's really nice because we can manage all of our feature flags from this UI as well. And you can use it for feature flags, but you can also really use it to change any property dynamically at runtime if you really need to do that. So it's a gRPC service, and thankfully that makes it really easy to write a gem that wraps it. Increasingly, more of our services have been moving towards gRPC, allowing us more freedom to choose the right language for the job. Whereas traditionally, because all these services were written in Java and there was an expectation that other services would also be in Java, the only client that these teams would produce would be a jar. And now it's a lot easier for us to create Ruby clients for all of these different services that we use, and making it really simple for us to interact with other services in a very polyglot way. So using the gem is pretty simple. Your consuming applications don't really need to care or know how it communicates with that service. And then you can manage all of your feature flags through Spinnaker, which even has the ability to roll out this property change incrementally across regions. So for example, if your application was in multiple regions, you could roll out a property change to one region first and then slowly roll it out at regular intervals to other regions. So if in case you broke something with that property change, you have the opportunity to roll it back. And because it also exposes a RESTful interface, our UIs can even speak directly to it to access UI-specific feature flags. Another common feature we've extracted is commenting. Cacophonics is comments as a service at Netflix, and as you can probably guess, it allows you to comment on anything. Some of our applications have recently started using this service, while others are slowly migrating. This application, in particular, Origin Story, also has WebSocket support for real-time comments. So that's all fine when you're building Rails applications, but if you're writing a smaller microservice in Ruby, one of the things that you need to care about in the Netflix ecosystem is about service discovery. And service discovery is used for locating services for the purposes of load balancing and failing over middle-tier services. And at Netflix, our internal service registry is called Eureka. As I mentioned before, mid-tier services that are not already fronted by a load balancer typically need to be load balanced by Eureka instead. And in the studio space, we tend to have application load balancers in front of our APIs. And also, we have Route 53 in front of them. So Eureka isn't really heavily used in a lot of our APIs. But again, if you're writing a smaller microservice, this is one of the ways that other services can discover and interact with your microservice, because the IP is not fixed, right? It's always changing. And of course, we also wrote a gem. So we have a lot of gems, we have a lot of services. So I've given you a pretty high-level overview of what it's like to develop studio applications at Netflix. We started out writing very simplistic, very vanilla Rails applications. We totally abused active model callbacks, which was not fun. But increasingly, we're moving towards a highly distributed, data-intensive environment. And our organization is still really young. We're about 2 to 3 years old. And we're really just at the beginning of scaling up our engineering efforts. It's still a very long road ahead, but we're excited about scaling up more to tackle these challenges. There's billions of dollars worth of content, and the viewables numbering in the hundreds to the thousands. Some of our technical challenges ahead are getting Ruby on the Netflix paved road with even more platform support, and also contributing back to the community with our open source work. And also generally moving fast without breaking things. Again, our challenges are not so much about throughput, but rather the fact that we collect so much data about these content that we're producing. We need to build a lot of different services to make sense of this data, to make sense of it all, and to help our creatives unlock some key insights about the originals that we're producing for our users. And that means partnering really closely with our data science team to build models that we can use. So we covered a lot today. We first spoke about the origin story of Netflix and how we're constantly improving, innovating, and taking on big bets. When we first started out producing our own original series, it went great, and we wanted to do more. But we soon realized that we weren't equipped to scale this up. We built our first studio application in Ruby because really the studio engineering organization we kind of see it as a very well-funded internal startup within Netflix. And what we want to do is to allow our teams to be very fast and very creative. We continue to choose Ruby for a simple reason, that Ruby makes our teams happy, curious, and eager to innovate. And most importantly, with the kind of work we do, which is reinventing the way that this content is being made, it's really important that we have empathy for the people whose work relies on ours. To do that, we shared the pain. We extracted common features into way too many services that are maintained by a lot of dedicated teams. And we're building the studio on top of this platform, allowing us to move faster as we scale up for these operations. If you're interested in helping us, I'm hiring, so there's a link below. If you like working with a lot of microservices and being frustrated by latency, come talk to me. But thank you for having me.